Hello, let's continue our Sudoku adventure with Yigu Yanduan by PjoeterBliep, and I'm sure I butchered that name. So let's go over the rules. We have normal 6x6 Sudoku rules, so in each row, each column, and each 2x3 box, we're placing the digits 1 to 6, exactly ones each. We also have these arrows in the grid. They are both arrows and Chinese whisper lines, so I'll just go over the rules separately and how those rules work. Part of this puzzle is thinking about how they work together, so I'm trying not to give that away, any of the logic away. I don't want to take that away from you if you're want to solve it yourself. So the way arrows work is whatever digits go on the arrow, you sum them and that value goes in the circle. So if this was 2, 3, 2 plus 3 is 5, we put a 5 in the circle. If it was 2, 4, we put a 6 in the circle. That's how arrows work. There is no additional non-repeat rule for arrows. So if this was a 2, this was a 2, that's fine. We just add to 4 and that would be fine. They are also Chinese whisper lines. The circle plus the arrow makes a full Chinese whisper line. And so the way they work is adjacent digits on the line have to have a difference of at most 2. So if this was a 2, this could be a 1 because the difference 2 minus 1 is 1. That is at most 2. It could be a 2 if we allowed repeats. So like here and here, it could be a 2 because that's a difference of 0. Could be a 3 because that's a difference of 1. Could be a 4 because that's a difference of 2, but could not be 5 or 6. 5 is a difference of 3, 6 is a difference of 4. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. Okay, so I'm wondering if we're limited on what we can add to in a 2-cell arrow. They're all 2-cell arrows. So I don't know. Like 1, 2, 3 is clearly possible. We could go 1, 1, 3, 4. That's possible. I think. Well, yeah. So if you think about it, whatever. Okay, this digit here, I think needs to be a 1 or a 2. Why do I say that? Well, if this was a 3, then whatever this is, we'll call it X. Maybe I can go to letter mode here. So we'll call that X. If this is X, this is X plus 3. And they're next to each other. And X plus 3 and X have a difference of 3, which is bad. So this has to be a 1 or a 2. This could be anything because we're adding 1 or 2 to it to make this digit. It just can't be 6 because we can't exceed 6. And so that's the same here. This has to be 1 or 2. If we try to do 3, 3, 6, then 3 and 6 are too far apart. So all of these on the arrow tips are 1, 2s. That's interesting. And then the rest of the arrow seems to just fall into place, doesn't it? We have at least 3 different sums here. I mean, we have 3 different sums here, I should say. Well, let's ignore ones like this where we can repeat. Let's think about all the other ones we can't repeat because they're in a row, column, or box. So if this were another 1 or 2, we'd add to 3. If this were a 3, we'd add to either... Oh, so this can't get that big, right? This can't be a 5 because 5 is too far from both 1 and 2. 4, we could go with 2 and add to 6. So the middle one can't exceed 4. They're from 1 through 4. And that makes a 1, 2, 3, 4 quad in this box. So this is a 5, 6 pair. 6 can only be achieved by doing 2, 4. One of these is a 2, 4. Either this one or this one is a 2, 4. And then the other one, the 5, we can't do 1, 4 because they're too far apart. So we'd be doing 2, 3. So they both need a 2. To add to 6, we need to do 2, 4. To add to 5, we need to do 2, 3. They both have a 2. So this contains a 2, which means this isn't. And this contains a 2, which means this is. So we're either 2 plus 3 or 2 plus 4 to get to 5, 6. And then same thing here. This is our 2. actually. This has to be R2 because the 2 in the box. This is a 1. And 2 plus 3 or 4 to get to 5, 6 again. And so this is a 1, and this 1 plus 1 equals 2. Okay, didn't expect that. That's a 1 now. Adding with 3 or 4 to get to 4 or 5. Oh, 1 can't go with 4, though. Has to go with 3. 4 is too far away, and so that makes that a 4. That makes this a 2. 2 plus 3 is 5, and that makes this 2 plus 4 is 6. All right, that's a 4. Finish the column with a 1. That's a 2. 2 plus 4 is 6. Perfect. This is a 1. 1 plus 2 is 3, or 1 plus 3 is 4, but 4 is in the row. So it's 3 and 2, and it should just be Sudoku now. Nice. So this is, let's do up here first. This is a 1, 5. We know that that's 1, that's 5. This is 3, 4, 6. That's not a 3. This column needs 5, 6. This is the 5, this is the 6. Here we need a 3, 5. This 3 tells us that's 5 and 3. Here we need a 4, 5. This is 4, that's 5, because that 5 there. 3 or 6, not a 6. So that's 3, that's 6, 4, and 3. 2 3s in the corner. All right. That's a 6. What do we need? Up here we need a 4 and a 6. That's 4, 6. And down here we need a 2 and a 5. That's 5, 2. All right. Nice puzzle, PjoeterBliep. I enjoyed thinking about the arrows. I think, yeah, the key deductions solved the puzzle, which I think was the point, which is you got to just think about the constraint. The arrow tip had to be a 1 or a 2, and then the center had to be a 1 through 4. And then the 1, 2, 3, 4 quad here was created, making 5, 6 pair, which forced a 2 onto here and a 2 onto here. The rest really flowed nicely. All right, well, how'd you do?